The universe is often depicted as a silent, static tapestry of light. When we look up, we see a gallery of frozen spirals and elliptical islands floating in the dark, giving us the impression of serenity. But this serenity is an illusion. To the eyes of our most advanced instruments, the cosmos is actually a violent, dynamic arena where gravity sculpts structure through cataclysmic collisions. Nowhere is this violence more evident than in the recent, groundbreaking unraveling of a system known as the Cosmic Cloverleaf. This specific system has completely rewritten our understanding of galactic evolution and solved one of the most puzzling mysteries of modern radio astronomy. Today, on Fun Facts Online, we are going to deep dive into the anatomy of this cosmic train wreck. We are going to explore the history of a mystery that baffled astronomers for years, the detective work that linked faint radio rings to a violent group merger, and the physics of the shockwaves that lit up the sky. To understand the significance of the Cosmic Cloverleaf, we first have to rewind to the discovery that set the stage. The story begins in late 2019, in the silent outback of Western Australia. The Australian Square Kilometre Array Pathfinder, or ASKAP, began surveying the sky with unprecedented sensitivity. Its mission was to map millions of galaxies, but as is often the case in science, it found something it wasn't looking for. Buried in the terabytes of data were faint, circular patches of radio emission. These weren't small anomalies. They were enormous, spanning hundreds of thousands of light-years, effectively larger than the Milky Way itself. Yet, strangest of all, they were invisible to optical telescopes. They had no central bright star and no obvious connection to the galaxies they surrounded. They were simply circles. Astronomers were completely stumped. Was it a glitch in the software? A reflection of earthly interference? As more were found, they were officially catalogued as odd radio circles, or ORCs. The name was essentially a scientific placeholder, admitting that we had no idea what we were looking at. Theories abounded. Some suggested they were the throats of wormholes. Others thought they might be expanding shells of a new type of supernova, or perhaps shockwaves from a binary black hole merger. For 5 years, the ORCs remained an enigma. They were ghosts in the machine, spectral rings that hinted at a violent process we couldn't quite see. That changed with the discovery of the Cloverleaf. Technically catalogued in association with a galaxy group near redshift 0.05, this specific ORC looked different. While it shared the characteristic ring structure of its cousins, it was messier and more complex. It wasn't just a simple circle. It had lobes and irregularities that earned it the moniker Cloverleaf. But the real breakthrough didn't come from looking at the radio waves alone. It came when a team of astrophysicists, led by researchers at the Max Planck Institute for Extraterrestrial Physics, decided to look at the scene of the crime with a different set of eyes. They used X-ray vision. Using the European Space Agency's XMM Newton Space Telescope, the team peered at the center of the Cloverleaf. Now, X-rays are crucial here because they act as the universe's thermometer. They are emitted by gas that has been heated to millions of degrees. If the ORCs were just gentle bubbles of gas, the X-ray image should have been faint or non-existent. Instead, the XMM Newton data lit up like a flare. The telescope revealed a colossal cloud of superheated gas, glowing at a staggering 15 million degrees Fahrenheit, or roughly 8 million degrees Celsius. This was no gentle bubble. This was the thermal signature of a massive, gravitational crunch. The gas was shaped perpendicular to the radio ring, filling the space between a swarm of galaxies. When the team overlaid the X-ray map with deep optical images from the dark energy camera, the culprit was finally revealed. The Cloverleaf wasn't a single galaxy blowing a bubble. It was a swarm. At the heart of the radio ring lay not one, but 12 distinct galaxies, packed into a volume of space that should normally host only 1 or 2. The pieces of the puzzle clicked into place. The odd radio circle was not a mysterious object in itself. It was the smoke from a gun that had just been fired. The gun was the gravitational merger of 2 entire groups of galaxies, smashing into each other at millions of miles per hour. This cosmic cloverleaf represents a specific and violent phase in the hierarchy of the universe, specifically the transition from a group to a cluster. We have to remember that galaxies are gregarious. They rarely live alone. The Milky Way, for instance, is part of the local group, a small family that includes Andromeda and about 50 smaller dwarf galaxies. But in the grander scheme, groups are destined to fall together to form clusters, which can contain thousands of galaxies. The Cloverleaf captures the very moment 2 independent groups, each containing roughly half a dozen major galaxies, collided. Let's break down the physics of this collision, because it is fascinating. Imagine 2 swarms of bees flying toward each other. In the vast emptiness of space, the bees, which represent the stars within the galaxies, rarely collide because the distance between them is immense. You could throw 2 galaxies through each other, and it is statistically likely that not a single pair of stars would physically crash. However, galaxies are not just made of stars. They are filled with the interstellar medium, clouds of gas and dust, and surrounded by a halo of tenuous, hot gas known as the intra-group medium. When the two galaxy groups of the Cloverleaf slammed together, the stars slipped past each other, but the gas clouds did not. They crashed with the force of 1 billion atomic bombs. The gas in the merging groups underwent ram pressure stripping and violent shock heating. The kinetic energy of the galaxy's motion was instantly converted into thermal energy, heating the intragroup gas to the 15 million degrees observed by XMM Newton. This superheated plasma is what generates the X-rays. It effectively traces the gravitational well of the merging system, outlining the chaotic potential energy pit into which the 12 galaxies are falling. This brings us back to the radio ring. When you have a collision this energetic, it drives a shock wave outward through the tenuous gas of the intergalactic medium, much like a sonic boom from a supersonic jet, but on a scale of 600,000 light-years. This shock wave acts as a cosmic particle accelerator. The universe is filled with what we call fossil electrons. These are old, low-energy electrons left over from ancient supernovae, or the past activity of supermassive black holes. On their own, these electrons are invisible. But when the merger shockwave sweeps over them, it kicks them, accelerating them to near light speed. As these relativistic electrons spiral around magnetic fields in the shock front, they emit synchrotron radiation, which appears to our telescopes as radio waves. The giant ghostly ring of the Cloverleaf is essentially the sonic boom of the galaxy crash, illuminated by these re-accelerated electrons. So who are the actors in this cosmic drama? The 12 galaxies identified in the Cloverleaf merger are a motley crew of ellipticals and spirals, each being traumatized by the event. At the center of the two merging subgroups are likely two massive elliptical galaxies. These are the gravitational anchors. As they spiraled toward each other, they dragged their satellite galaxies with them. Then, there are the stripped spirals. Several of the smaller members appear to be spiral galaxies that are losing their shape. As they plunge through the dense, hot gas of the merger center, their own gas is being stripped away in a process called jellyfish galaxy formation. They leave trails of star-forming gas behind them, doomed to become red and dead ellipticals as their fuel is stolen. We also see agitated nuclei. The merger has likely disrupted the central supermassive black holes of the 12 galaxies. The gravitational tidal forces torque gas into these black holes, causing them to flare up as active galactic nuclei. It is entirely possible that the fossil electrons lighting up the radio ring were originally spewed out by one of these black holes millions of years ago, only to be reawakened by the merger shock today. Now you might be wondering, if galaxy mergers happen all the time, why is the Cloverleaf so special? Why don't we see odd radio circles everywhere? The answer lies in the geometry and the timing. It requires a Goldilocks geometry. For an ORC to be visible as a perfect ring, we generally need to be viewing the shockwave face-on. If the merger were happening edge-on relative to Earth, we might see a complex mess or a relic structure, but not a beautiful circle. The Cloverleaf offers a rare, perpendicular viewing angle of the shock front expanding outward. It is also in an evolutionary sweet spot. The Cloverleaf is caught in a transient phase. If we looked a few 100 million years earlier, the groups would be too far apart to generate the shock. If we looked 1 billion years later, the shock would have dissipated, the gas would have cooled, and the 12 galaxies would have merged into a single, giant elliptical galaxy at the center of a new cluster. We are catching a fleeting moment of maximum violence. Furthermore, there is the matter of the fossil electron reservoir. The leading theory for why the Cloverleaf is so bright in radio waves is that the region was already polluted with high-energy particles. It implies that one of the 12 galaxies was a radio-loud quasar in the past, filling the surrounding space with plasma. When the merger shock hit this pre-existing plasma, it lit up brilliantly. Without that pre-existing reservoir of electrons, the shockwave might have been invisible to our radio telescopes. The study of the Cosmic Cloverleaf goes far beyond explaining a pretty picture. It serves as a laboratory for high-energy astrophysics and dark matter dynamics. We cannot see dark matter, but we know it drives these mergers. The visible galaxies are like corks bobbing on a river of dark matter. By modeling the dynamics of the 12 visible galaxies and the temperature of the X-ray gas, astronomers can map the distribution of the invisible dark matter halo enveloping the system. The Cloverleaf provides a unique test case for how dark matter halos merge and relax. It also helps us understand galaxy quenching. One of the biggest questions in astronomy is why massive galaxies stop forming stars. The Cloverleaf shows us the mechanism in action. The violent heating of the gas prevents it from cooling down to form new stars. Furthermore, the shockwaves strip the galaxies of their existing fuel. This merger is effectively a sterilization event, ensuring that the resulting massive cluster galaxy will be composed of old, red stars. It is a cosmic retirement home in the making. Finally, looking at this system gives us a glimpse into the future of the Milky Way. In about 4.5 billion years, our Milky Way will merge with the Andromeda galaxy. While that will be a merger of just two major giants, the physics will be similar. Looking at the Cloverleaf is like looking at a hyper-accelerated, magnified version of our own distant future. It reminds us that our galactic home is not a permanent fixture, but a fluid structure subject to the violent tides of gravity. The unraveling of the Cloverleaf mystery is just the beginning. We are entering a golden age for this research. As the Square Kilometer Array comes online, it will likely find thousands more ORCs. Astronomers estimate that ORCs might be more common than we thought, but most are too faint for current telescopes. Future X-ray missions like Athena will map the temperature structure of the Cloverleaf's gas with higher precision, allowing us to see the turbulence and weather inside the merger cloud. Spectroscopic surveys using instruments like the Very Large Telescope are now turning to the individual stars within those 12 galaxies, looking for tidal tails and streams of stars ripped out during the dance to reconstruct the exact trajectories of the collision. The Cosmic Cloverleaf is more than just a chaotic merger of 12 galaxies. It is a Rosetta Stone for understanding the violent growth of the universe. It bridges the gap between the invisible dark matter and magnetic fields, the thermal hot X-ray gas and the relativistic radio-emitting shockwaves. It teaches us that the empty space between galaxies is not empty at all. It is a reservoir of potential energy, fossil particles, and magnetic fields waiting to be awakened by the crash of cosmic giants. For 5 years, the odd radio circles were a ghostly riddle. Today, thanks to the Cloverleaf, they are recognized as the shock fronts of creation itself, the ringing bells that announce the birth of a new galaxy cluster. As the 12 galaxies of the Cloverleaf slowly spiral inward, destined to lose their individual identities and merge into a single supergalaxy, they leave behind a radiant halo that tells the story of their dramatic union across 600 million light-years of void. In the grand tapestry of the cosmos, the Cloverleaf is a knot being tied, a vivid, chaotic, and beautiful reminder that the universe is still being built, one collision at a time.